So hopefully you were able to connect the rolling count bolt, and I'll just show you the solution and probably more importantly, the process that I took to do it. So in the first hint, after creating your rolling count bolt.java file, and again, we're taking this code from the Apache Storm starter rolling count bolt file. After copying and pasting this into our project, the first thing we need to do is change the package name from storm.starter.bolt to our package. As an example, we can go to our tweet topology and see that our package is udacity.storm. We can copy and paste that into our storm starter bolt. I'll leave this as a comment. Next, we see the import statement used in the original storm starter is storm.starter.tools, and there are 3 of them in the import statement. We created our tools folder under storm, and so therefore our import statements are going to be udacity.storm.tools. I'll just copy and paste these. I'll comment out the originals, and I'll simply change these to udacity.storm. And there we go. What we'll now need to do is copy in nth last modified time tracker, sliding window counter, and tuple helpers into our tools folder. And we can find those with the path udacity.storm tools. Therefore, we come to storm, examples, storm starter, source, storm, starter, and tools. Remember, this is the structure of the storm starter source code. And we see we have nth last modified time tracker, sliding window counter, and we see in storm.tools we have nth last modified time tracker here, and we have sliding window counter here. Let's go ahead and copy those 2. And we create them in the appropriate place in tools. Add a file, nth last modified time tracker.java, and we'll paste that in. Let's make sure to change our package name to udacity.storm.tools, and we navigate back, come to our sliding window counter, copy, add a file in tools. Remember the name is sliding window counter, sliding window counter.java, and paste. And just to make sure, we see our nth last modified and our sliding window counter in our tools folder. Next, we come back to rolling count bolt, and we see that storm.starter.util is our tuple helper. And we'll just put those in the tools as well. So we want starter, util, and tuple helpers. We can copy and paste and complete the same exercise by going to tools, add file, tuple helpers.java, and we'll copy and paste that. And again, we remember to change this to udacity.storm tools. Make sure we do that with our sliding window counter too. Now, taking this approach, and we have 3 files, let's run a Maven package. And we see that we have an error, and the error is the slot-based counter. And this means that we have at least 1 additional file to copy. Back in Storm Starter Tools, we find the slot-based counter. And again, we see that here where the symbol class slot-based counter is missing. So we open slot-based counter, complete the process, copy. Let's add it again to Tools, add file, slot-based counter.java. Copy, paste, change the package name, udacity.storm tools, and let's rerun. And here we need to be careful on another build failure, and I'm just leaving this in to show you the process that I went through. And here we see the variable tuple helpers is missing. And it turns out that I have the same structure as udacity.storm util, but we don't have a util folder. I put tuple helpers in tools, so this needs to change. We'll Maven package again, and we have a build success. Finally, in step 7 of the written instructions, we want to ignore the count bolt and use the rolling count bolt. Remember that we'll have to check the rolling count bolt for the correct syntax. To do this, let's copy and paste an existing bolt. Let's ignore the count bolt, set the rolling count bolt component ID with a new rolling count bolt. Note that the default constructor for rolling count bolt with no arguments takes in the default sliding window in seconds and the default emit frequency in seconds. The default sliding window in seconds takes in the number of window chunks, which is 5 times 60. We don't want to wait this long, so we see that the rolling count bolt that takes in arguments window length in seconds and emit frequency in seconds. Let's use this constructor in our topology Here, for the rolling count bolt in seconds, and let's set this as 30 seconds with an emit frequency of 10 seconds. Finally, we want to connect this to our report bolt. And again, we can copy, comment out our old report bolt. Finally, once we connect our report bolt to the rolling count bolt, let's try and run this in Maven. Maven package, and we have a build success. Let's submit the job, storm jar target, udacity.storm tweet topology. And I'll leave it on the terminal simply because we see that we have a runtime error. Basically, the halting process that a worker died at the report bolt. And this is one of the difficulties of Storm that I've found after working through it, in that Storm has runtime errors that are usually type-based. So let's explore our rolling count bolt a bit more in detail to figure out what's happening. If we go to the report bolt, which is the worker that's dying, we see that the report bolt expects a tuple with a string word that's labeled word and an integer count of count. Looking deeper at the rolling count bolt, we scroll down to the emit function and the declare output fields. First, we see that the declare field is declaring an object and a count. Again, the report bolt is expecting word and count. To make it more robust, we could either change the report bolt to take in a string at location 0 and an integer at location 1, or we can change the field name to match the report bolt. I'm going to call object word in order to match the report bolt word and count. The next problem we have in the report bolt is that the count, looking up to the emit function, is a long. Therefore, we need to change the long to an integer to match our report bolt. To do this, we can use integer int count equals count if not null, and return the count.int value or null. And simply this is an if-then statement, and instead of returning count, we will return our in count. So therefore we have word and count. Word is as expected. We will get an object that's a string of the words that we're counting and an integer of int count. Finally, we just recheck our topology and see that the rolling count bolt is connected, and we'll go back to Maven package. Finally, we have a build success, and we'll submit storm jar target and submit our tweet topology. And we see now that the program continues to run, we'll open up our visualization, and we see that the rolling count bolt is now driving the visualization, and we know that the rolling counts of each word is being displayed. And finally, we know that we can take the rolling count bolt or other bolts that are open sourced, or spouts for that matter, and integrate them into our Storm topology to be able to use others' codes and develop more efficiently. Great job.